Hello and welcome to this FMSP recording for MEI M1. The topic we're going to look at today is vectors, and we're going to start by looking at the content of the unit. So you need to be able to understand the different language that would be used on the examination papers, including the word vector, scalar, unit vectors, position vectors and so forth. You need to be able to find the magnitude and direction of a vector that's given in its two-component form, and then you also need to be able to express a vector that's given in component forms in terms of its magnitude and direction. We need to be able to carry out elementary operations on vectors, things like adding and subtracting, multiplying by a scalar. And we're going to apply vectors to some of the other topics that you will have met in mechanics, such as topics to do with Newton's laws and forces. So, looking at the key points mentioned there, a vector is a quantity that has both a magnitude, that means a size, and a direction. It's usually represented by a straight line. The arrow can either be at the end or sometimes you see it drawn in the middle. A scalar quantity, by contrast, has no direction. It just has a size or a quantity. When we talk about unit vectors, we're talking about a vector of length 1, and the common ones that we come across are I and J, and if we're working in 3 dimensions we also have K. I is 1 in the X direction, J is 1 in the Y direction, and K would be 1 in the Z direction if we're working in 3 dimensions. The word position vector relates to a vector which is, if you like, attached to the origin, to a fixed point. So it's giving the location of an object in relation to an origin. Now, any vector can be expressed in terms of its components, normally measured horizontally and vertically. So, for example, this column vector 4, 3, which we sometimes write as 4i plus 3j, has a horizontal component of 4 and a vertical component of 3. Now, the magnitude of a vector is the length or the size of it, and we can work that out using Pythagoras' theorem. In this case, it's very simple. Hopefully you'll recognise that this is a 3, 4, 5 triangle. So the magnitude of this vector is 5. The direction of a vector varies from question to question, but commonly we give it in relation to the horizontal. So you would use trigonometry to work out the size of this angle, and you would say, let's say it's 40 degrees, you would say it's 40 degrees above the horizontal, or you might say it's 40 degrees below the horizontal. Sometimes examination questions ask you to measure from the vector J, which is vertically upwards. So we'd be after all of this. That would be the same if we were doing a bearing. And the answer would be 90 plus 40. So in that case, we'd have an angle, obviously, of 130 degrees. So make sure you read really carefully in the question where they're asking you to measure the direction of a vector from. Now, if we know the direction and magnitude of a force, we can write it in component form using trigonometry. So let's suppose the length of this vector is r, that's its magnitude, and let's suppose that that angle there is theta. And I want to know the horizontal component, so I'll call it x. In a second I'm going to want to know the vertical component. Now, using basic trigonometry, we can look at this triangle. We've got the adjacent and hypotenuse, so we know we're going to be involving cos. So we can write cos of theta equals adjacent over hypotenuse. And rearranging that, we get an expression that x is equal to r cos theta. Similarly, if I want to work out the vertical component, we've now got the opposite and the hypotenuse. So sine of theta is opposite over hypotenuse, and again rearranging it we get an expression y equals r sine theta. Now, depending on how you've been taught this, you may have been taught the rule that if you turn through the angle, it's cos, and if you were to turn away from the angle, in other words towards the vertical, then it's sine. So that might be a way you want to remember it. Through the angle is cos, and away from the angle towards the opposite side, the vertical, that is sine. So just before we go on to look at some exam questions, just a quick reminder of how to add and subtract different vectors. Here we have 2, 5 plus 3 minus 7. We just add together the individual components. 2 add 3, 5, and 5 add minus 7 is minus 2. Similarly, if we added these two vectors together, we would have 9 and 6. Same thing applies with subtraction. On this second example, if that was a minus in the middle, 3 take 6, that's minus 3, minus 2 subtract 8, minus 10. So it's as intuitive as it looks. Multiplying a vector by a scalar, in other words a number, you literally just multiply each of the individual components by the number. So 7 9s, 63, 7 times minus 4, minus 28. So straightforward arithmetic there. One final point, if it says that we're looking for a resultant vector, what we do is we add together all the individual vectors. So there might be a situation where you've got a few forces acting on an object and you want to work out the resultant of those forces. So you would add together all of those vectors. So let's start looking at some examination questions. That's the question in full, so you may wish to pause the video and have a look through the individual parts. And then let's start having a look at part 1. So I is horizontally and j is vertically as usual, unit vectors. And we've got a force minus I plus 5j, so that's minus 1 plus 5. So on the diagram here, you can see I've drawn a line to the left of length 1 and a line upwards of length 5. So the vector's going over in this direction. Notice I haven't put the minus 1 because I'm just interested in the length of the side when I'm looking at this triangle. I've indicated the direction by the way I've drawn my picture. So we have to calculate the magnitude of f, which is sometimes written as 2 vertical lines, and we tend to underline vectors when we're writing them by hand. So the magnitude of a vector can be found using Pythagoras. Here we've got 5 squared plus, I'll put that minus 1 in brackets to remind me that it's positive when it's squared, and so we get an answer of root 26, which rounds to 5.10 to 3SF. We also need to calculate the angle between f and the upward vertical. Now the upward vertical would be up there, and so we want this angle here, which I'll call alpha. So what I'll do to start off with is I'll work out this angle here, theta. We've got the opposite and the adjacent, so tan theta, opposite over adjacent. And if we do inverse tan, we'd have theta is the inverse tan of 5. And if you get your calculator, that works out to be 78.7 degrees. So that's this larger angle here. So the angle with the vertical, alpha, would be 90 minus 78.7, and that works out to be 11.3. So that's 4 marks, fairly straightforward. We get a method mark here for showing that we're applying Pythagoras, and an accuracy mark for getting the correct answer. And then on the second one, they're looking for some kind of indication that you use in trigonometry, but also that you're considering the correct angle. So they'll be looking for the 90 minus this tan theta value. So both of those things would be needed for your method, and then the accuracy obviously gets you the next mark there. So that's part 1 of that question. Now, part 2, we've got a few different forces. We've got G and H, and if we just pop back to the last slide, F is minus I plus 5J. So let's write that down. F is minus I plus 5J, because it's used again in this question. So it tells us that the resultant force H is the resultant of 4F and G. Now the resultant force is when you add them together, so it's saying that H is basically 4F plus G. Now you can either write these vertically or horizontally, it's up to you. So h is minus 2i plus 3b times j, and then we have 4f plus g. Now that looks quite complicated as it sits, so what we tend to do is we collect together the I and the j components. So on this right hand side I've got minus 4i here, and I've got 2a times I there, so I can write that all together as 2a minus 4 times I, 2a minus 4. Similarly with the j's, I've got an a from the second bracket, and I've got plus 20 from the first bracket. So if these two vectors are equal, we know that the i's must be equal and the j's must be equal, so we can form two equations. So we can have minus 2 equals 2a minus 4 from the i's, and we'll have 3b equals a plus 20 from the j's. So looking at the first of these equations, if we go ahead and solve it, we'll get 2a equals 2, so a equals 1. Subbing that into the next one, that means that 3b has a value of 1 plus 20, 21, so b must have a value of 7. Make sure we read the question carefully. We have to actually find g and h, not just the values of a and b. So we sub those back. G, if we go back to the top, it's here, 2ai plus aj. So if a is 1, that would literally just be 2i plus j. And for h is here, it's minus 2i plus 3b, so that's 21j. So that's worth 4 marks in total. The first mark is for forming this equation of the resultants, that's a method mark. And then for getting down to at least one of these two equations here would get you a second method mark. Getting down as far as a is 1 gets you an accuracy mark, or indeed getting this force g, and then for getting it fully correct would get you the 4th mark there. So that's an 8 mark question in total on vectors. Let's move on to another one. This is in vertical column notation, and this time it's in 3 dimensions. So again, if you want to pause the video and have a look through the full question, and then let's look at the individual parts. So we've got 3 forces. We have minus 1, 14, minus 8, 3, minus 9, 10, and F. And they act on a body of 4 kilograms to give it an acceleration of minus 1, 2, 4. Now this is using one of Newton's laws, because we've got forces and mass and acceleration, so hopefully you will recognise this formula, and I'm underlining them to show that we're using vectors. So this F here doesn't mean the F in our question, but it means the resultant force. So what we need to do is add these together to get the resultant force, and that will be equal to the mass multiplied by the acceleration. So let's work that out. These two vectors here, well, they'll add together to give 2, 5, 2. So 2, 5, 2 plus F equals, multiply this by 4, we get minus 4, 8 and 16. So you can either use common sense or bring this vector over to the other side and subtract. F must be minus 6 plus 3 and 14. So looking at where the marks are allocated, well, you get a method mark for putting together the F equals MA statement, and you get a method mark for showing that you can manipulate the addition of these two vectors. You get 1 accuracy mark for getting at least 2 of these components correct in the answer, and you get the last mark if you get all 3 of those correct. Let's have a look at the next part of the question. So at one instant, the velocity of a particular body is -336. It's the same body as last time, so the acceleration must be the same. That is -124. That's the same as the first part of the question. We're interested in what's happening 3 seconds later, and we're interested in the velocity. So that must mean that we're using this speed or velocity as our starting value. So we call that u, and we're talking about kinematics here. So we need to find an equation that involves u, a, t and v. So hopefully this equation has jumped into your mind. So we just substitute in the things that we know. U is -336, a is -124, and t is 3. So being really careful, just multiply the second vector by 3, not the first one. Have a little go at that yourself. Check my numbers. I think you get -69 and 18. Now it's tempting to stop at that point, but we've got to read the question carefully. Also the speed. We found the velocity. Velocity has direction, that's a vector, whereas speed is a number, that's a scalar quantity. Now, just like in 2 dimensions, you can use Pythagoras' theorem. Well, we can use Pythagoras' theorem in 3 dimensions to find the magnitude of this velocity, in other words, the speed. So we'll have -6 squared plus 9 squared plus 18 squared. And if you use your calculator to work that out, or do it in your head, √441, which works out to be 21 meters per second. So the allocation of the marks, you get 1 mark for choosing the correct equation. And you get a mark here for getting to the correct answer. That's an accuracy mark. Same again on the second part. A method mark for showing that you're using Pythagoras, and then an accuracy mark for executing that correctly. Let's move on to the next question. We've got, again, the full question here if you wanted to pause and have a look. So let's have a look at part 1. It says, calculate the bearing of the vector -4, -6i. So I've already drawn a diagram here. -4 is to the left, but again, I'm just going to label it as a length of 4. And -6 is down, but again, I'll just label the length, so that's 6. And because we want a bearing, I've drawn in a north line here. I'm going to be measuring round from north like we do with bearings. But first of all, I'm going to find this angle here using trigonometry. Opposite and adjacent are known, so tan theta, opposite over adjacent. So theta will be inverse tan of 6/4, or 3/2, and that works out to be 56.3 degrees. Now we know that all the way around to the west line, this is west, will be 270. So 270 minus 56.3 gives us 213.6, and I'll round that to 3SF to 214 degrees as a bearing. 2 marks for this, 1 mark for applying the trigonometry, and then 1 mark for accurately getting the answer. Let's have a look at part 2. A little bit more complicated this time. We have a vector that has a k here, a scalar, and it is in the direction of 7i minus 9j. In the direction of means parallel to, and you can think of that as being a multiple of. So if something's in the same direction, its components will be in the same ratio. So, for example, another vector that's in this direction would be 14i minus 18j. It's going in the same direction, it's just twice as big. And what you would always find is that the ratio of the y or j component to the I component would be 9 over 7. Here it would be 18 over 14, which is the same, 9 over 7. And we have this minus in the middle that we need to just be a little bit conscious of. So going back to the question, the first thing I'm going to do is I'm going to write this with the i's together and the j's together. So, like we did in an earlier question, I've got minus 4 plus 3k, I, and then I've got minus 6 minus 2k, j. Now, because it's parallel to this vector that's got a negative in the middle, I'm actually going to slightly rewrite this. I component stays the same, but I'll take a factor of minus 1 out of the second component. So it's got a minus in the middle in the same way that this has, and so we can just look at the actual content of the brackets. And we know the content of that brackets has to be in the ratio 9 over 7. So we know that the ratio of the j component, neglecting the negative because there's one here and there's one there, the ratio of the j component to the I component must be 9 over 7. So if I cross multiply, I'm going to get 42 plus 14k, I'm sorry, I've got an extra one in there, is equal to minus 36 plus 27k. And if you go through and solve that equation, it turns out that k is 6. So we get 1 mark here for combining together the i's and the j's, so we can manipulate things a little bit better. And then we get M1 and A1 for forming a correct expression. Just be careful with the signs. You could have left the negative in if you'd wanted to, but you'd have to have a negative in that one and a negative in that one to make sure you got the same answers. And then an accuracy mark for the correct answer. Okay, one last question. So again, pause the video if you'd like to read through it in full. And let's have a look at part 1. So we've got two forces acting at a point, and we've got our I and J drawn on the picture here, and we have got to find the resultant of these two forces. So let's have a look at what's happening horizontally to start off with. To the right is positive, so I've got 10 to the right, and then this force will have a component to the left, and it will be turning through an angle of 50. Because it's to the left, it'll be negative. It's going the opposite way to the positive I direction. So this would be 8 cos 50. If you remember, we had this formula earlier on. 8 cos 50, but it'll be to the left, so it's negative. And working that out gave me 4.86 to 3SF. If we then look vertically, this force doesn't have a vertical component, it's all horizontal. So it's only this force that's going to have a vertical component, and because we're going away from the angle to the perpendicular, it would be 8 sine 50, and it's vertically upwards, and that's positive direction, so we don't put a negative sign in this one. Working that out on the calculator is 6.13, and so this resultant force in terms of I and J is 4.86 in the I direction and 6.13 in the J direction. So we get a method mark for resolving the forces, like in here, and then we get an accuracy mark for getting either one of the components correct and a second accuracy mark if they are both correct. Okay, remember those numbers because we need them on the next slide. Last part, we have to calculate the magnitude of F. So it was 4.86 horizontally and 6.13 vertically. So the magnitude of F is the square root of 4.86 squared and 6.13 squared. And if we work that out, we get 7.82 newtons. And I've done that to 3 significant figures. We also have to calculate the angle that F makes with the upward vertical. Upwards, this angle here, I'll do the same as I did last time. If I call that alpha and I call this theta, tan theta is opposite over adjacent. And using inverse tan on your calculator, theta works out to be 51.6. That means that the angle alpha with the upward vertical will be 90 minus 51.6, and that works out to be 38.4. So for this part of the question, we have 3 marks available. We have a mark here for getting the correct magnitude, so just showing this number somewhere in your working. We have a method mark for doing trigonometry and subtracting from 90 to make sure you're doing the correct angle. And then we have a follow-through mark here. You would get this mark correct if your answer followed through correctly from the values that you'd obtained earlier. So that's the last example. I hope you've enjoyed the video, and I look forward to seeing you for the other topics in MEI Mechanics 1.